Hello everyone. Today we are going to solve problems on acute angle between two straight lines. When equations of the straight lines are given or when slopes of the straight lines are given. So we are considering two types. Type number A, in which equations of two straight lines are given. Example number 1 is x plus 5y is equal to 11 and 5x minus y is equal to 11. Example number 2, 3x plus 2y plus 4 is equal to 0 and 2x minus 3y minus 7 is equal to 0. And example number 3 is 3x is equal to y minus 4 and 2x plus y plus 3 is equal to 0. Example number B is slopes of the two straight lines are given, that are root 3 and 1 upon root 3. So now solution for this. First of all, let us solve example number 1 from A. Given lines are x plus 5y is equal to 11 and 5x minus y is equal to 11. Consider equation number 1 and equation number 2 for these two lines. Hence, taking 11 on left hand side, first equation becomes x plus 5y minus 11 is equal to 0, and taking right hand side on left hand side in equation number 2, it becomes 5x minus y minus 11 is equal to 0. Hence, comparing equation 1 and equation 2 with general equation of straight line, that is ax plus by plus c is equal to 0. Then in equation number 1, coefficient of x is a1 which is equal to 1 and coefficient of y is b1 which is equal to 5 and constant term c1 is equal to minus 11. Similar to this, in equation number 2, coefficient of x is a2 which is equal to 5, coefficient of y is b2 which is equal to minus 1 and constant term c2 is equal to minus 11. Now we have to find out slopes of above two lines. You know formula for slope. Slope is equal to minus coefficient of x divided by coefficient of y. So slope of line 1 is equal to minus a1 divided by b1, and which is equal to m1 is equal to minus 1 upon 5, and slope of straight line 2 is given by minus a2 divided by b2, but you know a2 is 5 and b2 is minus 1, hence slope is equal to m2 is equal to minus 5 divided by minus 1, and after simplification it becomes 5. Now we can find angle between two straight lines, and formula for angle between two straight lines in terms of slopes is given by theta. Theta is equal to tan inverse in modulus sine m1 minus m2 divided by 1 plus m1 into m2, where m1 and m2 are slopes of line 1 and line 2. Hence theta is equal to tan inverse minus 1 upon 5 minus 5 divided by 1 plus minus 1 upon 5 into 5, because m1 is minus 1 upon 5 and m2 is 5. Hence, after simplification, theta can be written as tan inverse in modulus sine minus 1 minus 25 divided by 5, which is numerator, and denominator becomes 5 gets cancelled, hence 1 minus 1, that is 0. Hence theta is equal to tan inverse in modulus sine minus 26 upon 5 divided by 0. And you know minus 26 upon 5 divided by 0 is infinite. Hence theta is equal to tan inverse infinite. And you know tan inverse infinite is equal to pi upon 2. Hence theta is equal to pi divided by 2, which is angle between line 1 and line 2. Theta is pi upon 2, meaning of this is what? Line 1 is perpendicular to line 2. Let us solve second sum. Given two lines are 3x plus 2y plus 4 is equal to 0 and 2x minus 3y minus 7 is equal to 0. Line 1 and line 2. Now we have to compare these two lines with general equation of straight line, which is given by ax plus by plus c is equal to 0, which is general equation of straight line. Comparing equation 1 with general equation, coefficient of x in equation 1 is a1, which is equal to 3, and coefficient of y is b1, which is equal to 2, and constant term c1 is 4. And in equation number 2, coefficient of x is a2, which is equal to 2, coefficient of y is b2, which is equal to minus 3, and constant term is minus 7. And you know slope of straight line 1, m1 is equal to minus a1 upon b1. Put the values of a1 and b1. Hence m1 is equal to minus 3 divided by 2. Similar to this, m2 is equal to slope of straight line 2, and which is given by minus a2 divided by b2. And you know a2 is 2, b2 is minus 3. Hence minus 2 divided by minus 3 is equal to 2 upon 3. We have obtained slopes of line 1 and line 2. So m1 is minus 3 upon 2 and m2 is 2 upon 3. Let us apply formula for finding angle between two lines, which is theta. And here theta is acute angle between the line 1 and the line 2. Hence formula for theta is tan inverse in modulus m1 minus m2 divided by 1 plus m1 into m2, where m1 and m2 are slopes of line 1 and line 2, which is equal to tan inverse in modulus sign minus 3 upon 2 minus 2 upon 3 divided by 1 plus minus 3 upon 2 into 2 upon 3. Simplify this. Hence theta is given by theta is equal to tan inverse, LCM of numerator is 6, so minus 9 minus 4 divided by 6 whole divided by LCM of denominator is also 6, but here 2 gets cancelled, 3 gets cancelled, hence denominator becomes 1 minus 1, hence which is equal to tan inverse of minus 13 divided by 6 divided by 0, which is nothing but theta is equal to tan inverse infinite, which is equal to pi divided by 2. Hence we can say angle between given two lines is pi upon 2. Hence line 1 is perpendicular to line 2. And you know condition of perpendicular lines is product of the slopes is equal to minus 1. You can satisfy that also. Let us consider example number 3 from A. That is, given lines are 3x is equal to y minus 4 and second line is 2x plus y plus 3 is equal to 0. Consider this as equation number 1 for line 1 and equation number 2 for line 2. Let us compare these two lines with general equation of straight line, and which is nothing but ax plus by plus c is equal to 0. Hence, coefficient of x in line 1 is a1, which is equal to 3. Coefficient of y is equal to b1 is equal to minus 1, and constant term c1 is equal to 4. Similar to this, in second line, coefficient of x is equal to a2 is equal to 2, coefficient of y is equal to b2, which is equal to 1, and constant term is c2, which is equal to 3. Hence, slope of line 1, which is given by m1, is equal to minus a1 upon b1, but you know a1 is 3 and b1 is minus 1, hence minus 3 upon minus 1, this is equal to 3, and m2 is equal to slope of line 2, which is given by minus a2 divided by b2, but you know a2 is 2 and b2 is 1, hence this is equal to minus 2 upon 1, which is equal to minus 2. We have obtained slopes of line 1 and line 2. Now consider theta is acute angle between these two lines, line 1 and line 2. Then using the formula we can find theta. You know theta is equal to tan inverse in modulus sine m1 minus m2 divided by 1 plus m1 into m2. This is equal to, substitute values of m1 and m2, hence tan inverse of 3 minus 2 divided by 1 plus 3 into minus 2. Simplify this, hence theta is equal to tan inverse in modulus 3 plus 2 is equal to 5 divided by 1 minus 3 into 2 is 6. Hence this is equal to tan inverse of, in modulus sine, 5 divided by minus 5, which is equal to tan inverse, 5 gets cancelled, tan inverse of, in modulus sine, minus 1. Hence theta is equal to tan inverse 1, because modulus of minus 1 is 1. But you know tan inverse 1 is pi upon 4. Since modulus of minus a is equal to a. Now let us solve example number B, where slopes of two lines are given, and here we have to find out acute angle between given two lines whose slopes are m1 and m2. Here slope of line 1 is equal to m1 is equal to square root of 3, and slope of line 2 is equal to m2 is equal to 1 upon square root of 3. Then theta is suppose acute angle between these two lines. Hence theta is given by formula tan inverse modulus of m1 minus m2 divided by 1 plus m1 into m2. And we know m1 is root 3 and m2 is 1 upon root 3. Substitute these values. Hence, which is equal to tan inverse root 3 minus 1 upon root 3 divided by 1 plus root 3 into 1 upon root 3. Simplifying this, theta can be written as theta is equal to tan inverse in modulus root 3 into root 3 minus 1 divided by root 3, considering root 3 as LCM of numerator. And in denominator, root 3 gets cancelled. Then denominator becomes 1 plus 1. Simplify this. Hence, theta is equal to tan inverse. Numerator becomes 3 minus 1 divided by root 3 divided by 1 plus 1 is 2. Again simplify this. 3 minus 1 is 2 in numerator. Hence tan inverse modulus of 2 upon root 3 divided by 2, which is equal to tan inverse 2 upon root 3 into 1 upon 2. 2 gets cancelled. Hence theta is equal to tan inverse 1 upon root 3. And you know its value, tan inverse 1 upon root 3 is given by pi upon 6. But you know pi upon 6 is value of angle in radian. And if we express this angle theta in terms of degrees, then this is nothing but theta is equal to 30 degree. Hence the solution. Thank you all. Thank you for watching this video. Thanks a lot.